Okay guys, let's look at example 11. So this is on asking you to prove that PQ is a perpendicular bisector of the line AB. Okay, do you still remember how it was drawn or not? To prove something whether it's perpendicular bisector, you first need to remember how it was constructed. Okay, I'm going to go through it together with you now, okay, on how it was constructed in the first place. So let's look at the screen. Here is my PQ. Here is my AB. How did I construct the angle bisector? The perpendicular bisector. Let us take a look. I first, okay. So first, I adjust to more than half, slightly more than half. Don't have to extend fully. You want to extend fully also can. You just have to make sure it's more than half. Then after that, I fix the length. Okay, and then I draw an arc. And okay, it's a bit wonky. Alright, then I draw another arc here. After that, using the fixed length, I move it here. And I draw an arc and make sure that I get across. And I move it to the top. And I draw it also to make sure that I get across. And then I'm done. After that, I will connect then. After that, I will connect the line, the 2 points, and this is my point P, and this is my point Q, and this is the intersecting point is R. Okay, so that's how we got it. So looking at this, if I want to prove that, I want to find out whether they are congruent to each other, first I need to look at the way that I constructed it. Remember, I mentioned in the previous video on the use of radius. Okay, so here, can you see that AP is going to be exactly the same length as BP? Okay, because they have the same radius. It's the same fixed length that I use the compass to move from one side to another to draw it. Okay, so therefore I can first prove that AP equals to BP. Then second one, let's look at my drawing. At the other side, AQ and BQ here, I will have a similar idea. Okay, it's just one top, one bottom. AQ is therefore equals to BQ. Then I share one common length here. You look at this line. This is a common length that I use to cut them. Okay, so what I have here would be PQ equals to PQ, because this is a common side. Then therefore, I can prove that SSS that rather I need to write down triangle first. I can prove that APQ and triangle BPQ are congruent to each other, and I can say that this is SSS congruent test. But we still haven't really answered the question, right? Because the question is asking us to prove that they are perpendicular bisector. But having proven that they are congruent to each other, I can therefore say that angle APR is equals to BPR. You get it? APR is equals to angle BP, different color, equals to angle BPR. These two are equals to each other because they are congruent. Okay? Then, having said that they are the same angle, and we can also then say that AR is equals to BR. Okay, therefore we can say that triangle APB is an isosceles triangle. Now once we have shown that AP B is an isosceles triangle, this, just draw this big one, this is an isosceles triangle. Okay, then we can say that this angle in blue and this angle in blue are gonna be equal to each other. Okay, so hence angle PAR is equals to angle PBR. And because these two triangles also share the same length, look at this side, they also share the same length here. So I will say that PR is equals to PR because of common side. Once I show that it is a common side, I can then prove that triangle APR is congruent to triangle BPR. This will be my AAS congruent test. Okay, so I have proven that some triangles are congruent to some triangles over there already. In the next step, what I can show is AR is equals to BR. Okay, you look back at the diagram. I'm gonna erase it for you to see. AR will be the same length as BR. Okay, reason is because then I can say that PQ bisects AB. So we know that it bisects AB already. Done. Because they are the same length, we can say that they bisect each other, and therefore we can say that PQ bisect. So we are done. With only one word, bisect, then we still need to prove that they are perpendicular to each other. Okay, we have only proven that it is bisect, but we haven't proven that it's perpendicular. So there is still a second part to it. Okay, now since it is on a straight line, I can say that angle ARP plus angle BRP is equal to 180 degree. And since angle ARP is equal to angle BRP, then I can say that angle ARP is equal to angle BRP is equal to 90 degree. Because they're equal, so I have to divide by 2. Therefore, I can say that PQ is perpendicular to AB. Now, I'm done with 90 degree perpendicular. So there are two parts for me to prove. Prove that they're perpendicular and prove that they bisect. Only then I can finally conclude. Therefore, PQ is perpendicular bisector of AB. Then I can write proven. Okay? Thank you very much.